Hello, let us see the motivation for addressing mode, that is why the addressing modes are essential. Before starting that, consider a particular memory layout or the content of memory locations. So this is the memory. Consider two particular values. For example, we are considering the values 30 and 50. Okay. Now the content of 30 and 50 are, suppose they are stored in 60A0H location and this 50 is stored at 70A0 location. Now apart from this, consider another two different memory location. Suppose 2020, this location holds the effective address of 30, that is 60A0. So 2020 will hold the value 60A0. Similarly, another memory location which is 3020 will holds the effective address of 50, that is 70A0. So this location contains 70A0. Now consider the add instruction, this one, add R1, R2. Now this instruction perform the addition of the content of R1, R2 and store the result back to R1 register. Now consider another add instruction which performs the addition where the operands are specified in terms of memory address. So consider this instruction. Now what is the meaning of this instruction? This instruction will perform the addition of the memory location 60A0 with the content of the memory location 70A0 and it will store the result back to memory location 60A0. Now consider the third type of instruction, add at the rate 2020, comma at the rate 3020. Now what is the meaning of this instruction? The meaning of this instruction is that written here, and store the result at 2020. Now what is the meaning of this instruction? This third add instruction says that content of this location. So m of 2030 holds the value 60A0, that is it actually adds the value at 2060A0 with the content of 70A0. So here this will become m of 60A0. Now the value of 3020 is 70A0, so it will be again m of 70. So more or less this instruction or this instruction more or less same, but in the first case we have to access the memory one time to access the operand, but in the second case we have to access the memory two times to access the actual operands, which are 30 and 50. Now from here we can see that all the three different add instruction here, all the three different add instruction are using the operands which are stored at different location. In the first case the operands are stored in register, in the second and third case the operands are stored in memory location, but there is a difference between the second and third case. What is the difference? Here in order to access the operand we have to access the memory only one time. In the third case, if we want to access the operands, we need to access the memory two times. So here we are accessing memory two times. Now although all these three instructions using the same add instruction, but how the processor will know how to evaluate the operands? So here is the solution, that is the addressing mode. That is, all these instruction use a special bit to indicate the location of the operands. So here we are using three different location for operands, so we can use at least 2 bits to distinguish between them. So we can use 00 at here, 01 and 10. Now how these binary bits can help us? After the add, if we see the 00 bit, we'll be sure that the operands are in registers. In the second case, after the add, if we see 01, then we will assume or we will interpret the two operands as memory address. After the add instruction, if the value is 10, then we will interpret this as the address of the effective address. So these bits are basically called the mode bit. These bits are called the mode bit, and this is the reason why the addressing modes are used. Thank you.